question, calculating the center of a circle. Remember what we did with the donut? So I'm trying to enhance our learning a little bit. We had a circle. What did we do? Find 2 points on a circle. We connect them. A chord. So step 1, draw a chord. We found the middle. We did a perpendicular bisector. Repeat. We needed another chord. So 3. Repeat. 4. Where repeat 1 and 2. Where the perpendicular bisectors intersect is the center. That was it. So all we needed to do is calculate the center. I didn't ask for any math. How you actually calculate the perpendicular bisector and all that. A little bit complicated. Just want to make sure you understood the concept. That's all we did with the donut exercise. Pretty easy concept, right? A little bit disappointed that we didn't remember that from eating the donuts, I guess. I guess that's the part we all remember. But not what is the learning opportunity there. Okay, so that was the first question. The last question was not done well as well. Was not done well. But I'll do another example of that today. Right? We just have issue of actually calculating this perpendicular bisector. Okay, so I want to take this up really quick. So I've already taught you all the tools that you need to learn for this unit. Calculating midpoints, calculating length of a segment, doing slopes, and calculating equations of a line. That's all reviewed from grade 9. Calculating where points intersect. 2 lines intersect. That's a review of the very first unit we did. So it's a good opportunity to go back and look at some of that stuff. Okay, so we want to verify that the line segment between points A and C and B and C is parallel to side AB. So the first thing you did was just sort of draw a triangle, right? So we got A, B, C. We want the midpoints of B and C. So screaming at you is what the first thing you should do. What's the first thing we need to do? Yeah, find the midpoints of A and C and B and C. So the midpoint of AC first. Okay, please remember our formulas. Few cases I saw x1 minus x2. Remember, midpoints is just our average. The averages of the 2 coordinates. When we do averages, right, when you average your marks, are you subtracting your marks to get that average? No, you add them up. So that's how you kind of remember that. So A is 1 plus 7 over 2, and Y is 3 plus 5 over 2. So we got 8 over 2 and 8 over 2. We got 4 common 4. If we actually drew our diagram, if we labeled it, that looks roughly about right. Okay. So that's the one midpoint. So the midpoint of BC. So same formula. x1 plus x2 over 2, y1 plus y2 over 2. So that's equal to 5 plus 7 over 2 and 5 plus 1 over 2. So I got 12 over 2 and 6 over 2, which gives me the point of 6 comma 3. Okay, and again, if we plot that on our graph, that looks roughly about right. Okay, So we have our two midpoints, but what is it asking for about those two midpoints? Rob?
The length of the line between the two midpoints?
Yeah, so we have this length here. Or sort of this segment that's connecting those midpoints. So we could give another letters. We could call this D. We call this E if we want. Okay? So we sort of replace MAC with D and MBC with E, so that once we start writing this other stuff, we don't have to write as much. What is it that we want to show with that segment though, with that new line segment? Yeah, so it's parallel to AB. So what is it that we need to calculate then? Okay. Well, that's the second part. In order to see if it's parallel, what do we need first to calculate if it's parallel? Yeah, we need the slope. So we need the slope of both segments. So the slope of, let's do AB first. Our slope formula again is delta y over delta x. y2 minus y1 over x2 minus x1. Unfortunately, when I was marking the quizzes, some people put the x coordinates up top and the y coordinates on the bottom, and we messed up the slope. Okay? We need to take extreme care with what we're doing. Okay? And I will admit, it is hard. I've screwed up many a times. Teaching these lessons, doing the work that this here on my own, we need to be focused, need that precision, need to stay focused. So here y2, AB, so I'll call this x1, y1, and this x2, y2. So I get 1 minus 3 over 5 minus 1. So that gives me negative 2 over 4, which is negative a half. If I look at our line, this is one thing that I want to encourage you to do. Draw a picture, right? So I visualize the slope of this. Is it a negative slope?
Yeah.
Yeah, it's going down, right? So at least chances are I got this part right. Now I want to calculate the slope of DE. And that's equal to delta y over delta x. So it's y2 minus y1 over x2 minus x1. So here I'm going to go up here to look at my points. I'm going to go this way, 4 minus 3 over 4 minus 6. And I get negative 1 over 2. That's MDE. So that's the slope of my new segment. So therefore, since MAB is equal to MDE, they are parallel. Or AB is parallel to DE. Okay? So that's how we prove that they're parallel. So we talk about being parallel and perpendicular, we're dealing with slopes. We need to calculate those slopes. Finally, what's the second thing that we're asked to do?
Find the length of both and see if DE is half the length of AB.
Yeah, so now we want to demonstrate or prove that the length of that new segment that we did, DE, is half the length of AB. So not only is it parallel to it, it's also half its length. So polar length formula, length of DE, let's do DE first, square root of that x2, y2. Okay, so in this formula, we're subtracting the x coordinates and subtracting the y coordinates. So somebody give me the x coordinates again for DE.
4 and 6.
So 4 minus 6 squared plus, and y2 was y, sorry? 4 minus 3, thank you. So that's equal to square root of negative 2 squared plus 1 squared, which is equal to square root of 4 plus 1, which is equal to square root of 5. So that's the length of DE, length of AB. Do you see why we need to keep practicing these formulas? We need these formulas over and over again just to prove certain concepts. So length of AB, the coordinates again, well, let me just write out the formula. x2 minus x1 squared plus y2 minus y1 squared. So what are my x coordinates for A and B? 5 minus 1, thank you. And the y? 1 minus 3. So that's the square root of 4 squared plus 2 squared. That's the square root of 16 plus 4, which is the square root of 20. If I simplify that radical, this is the same as 4 times 5. So that gives me 2 root 5. So is 2 root 5 twice as long as root 5?
Yes.
So that's the nice thing when we work with radicals, when we just keep it in radical form, it's easy to see that relationship as opposed to just convert it to decimal. It's kind of hard to see that it's actually exactly twice the length. Yes, Katie?
Do you have full marks? Do you have to put the root, like what you were saying just now? Or can I
No.
do it as just the square root?
Square root 20?
Yeah.
I'm not going to be picky on that because we didn't go over that. If you can simplify it to a simple radical, that's great. And when you do, in this case, is it easy to see that 2 root 5 is twice as long as root 5 as opposed to square root of 20 compared to root 5? It's harder to see root 20 is twice as long as root 5. But if I write it as 2 root 5, 2 times root 5, it's actually 2 times square root 5, right? So if you actually do that, it might help you see some of these things. Okay? Nora?
I forgot how to simplify that.
Okay. Caitlin?
Where'd you get the square root of
4 times. That's supposed to be 4 times 5. And I'm missing with the dot because it's supposed to be 4 times 5 either. Yes, Rob?
What if I were to convert the square root of 5 or whatever into decimals?
You could convert to decimals, and you could, again, it might be harder to see with the decimals, so it's twice. The nice thing about square roots, the radicals, you see that it's exactly twice as long. As soon as you convert to decimals, we lose some precision, but you'll probably see that it is twice as long.
Like for full answer, like we have to have a therefore statement, so we have to say therefore.
So yeah, so therefore,
AB is 2 times the length of DE.
AD is twice as long as DE. Okay.
Square root of 20. What's the one?
I haven't forgotten. I just want to get through this first and we'll talk about some final answers. So any questions on this example in particular? So it's just going off and calculating what you're asked to do. It's a little bit embedded in the wording. Again, just have to take care of our math so that we can actually see this. Nice thing about this question is I asked you to verify. So in other words, if you don't get these answers, then you know that you did something wrong. Okay, in other words, if your slopes weren't the same, then you probably did something wrong with either your slope calculation or your midpoint calculations. If your lengths aren't the same, then you probably did something wrong with your midpoints or your length calculations. Okay. So in that question, we had the square root of 20. Okay, so how I want to simplify this radical again was, can I factor 20 so that one of my factors is a perfect square? So what were my perfect squares again? 1, 4, 9. Well, here I can almost stop at 20, but you keep going. 16, 25, 36, 49, etc. So which, do any of those numbers divide into 20?
Yes.
4. So if I divide 4 into 20, I'm left with 5, right? In other words, 20 is 4 times 5. This is the same thing as square root of 4 times the square root of 5, right? So I can break up my square roots now that I have that multiplying in there. And the reason we want to do this is now what's the square root of 4? So we actually get an integer there. And now we're left with 2 root 5. So here's important, somewhat important thing that we just showed, a property. So the line segment joining the midpoints of two sides of a triangle is parallel to the third side and half its length. Okay, everybody got that down? Okay, so we'll walk through one example with you guys. It's a lengthy one. So we have a triangle with these three vertices, PQR. So the first thing you want to do is, again, just take a grid and just draw a triangle so we get a visual of what's happening here. So in reality, this question could have been just the last one. Determine the area of this triangle. The reason I made it to 4 parts is to help you see that you need, before you can determine the area of the triangle, you need the length of the altitude, right? Or the length of the height of the triangle. In order to get the length of the height of the triangle, you need a point segment on QR where that altitude intersects. But before you even get that, we actually need the equation of that altitude. Okay? So I sort of stepped it out on the process that we need to follow, just by breaking down into one question leads to another. So we'll only work on the first one here. So there's our triangle. So I want to determine the equation of the altitude from point P. But before we get the height, I need that equation first. Okay, so that was the first question. Was that the first question? Determine the equation of the altitude from point P. Yes, height. So how do we go about getting that point, or that equation? What's special about the altitude or the height of a triangle? Mo?
It goes like down the center, so find the midpoint.
Okay, so it doesn't quite go down the center. The altitude doesn't necessarily go quite down the center. It doesn't hit the midpoint. Okay, so if I had a triangle, so if I was the midpoint here, let's say that was the midpoint, this is not the altitude. Okay, we call that the median. Remember, that was the definition of a median. The median goes from a point to the middle of the opposite line of a triangle, opposite segment. Well, what special quality do we have about the altitude? Jake?
Can I give you the area?
Yeah, we need it for the area, right? It's area of a triangle is half of a base times altitude or height over 2. But what's that special quality about that line, that altitude or the height? Rob?
You have to find the length that takes the shortest distance from P to QR.
Well, that was question number 3, actually.
Right.
But what's that special quality about that altitude?
Perpendicular to QR.
Were you gonna say that? Yeah, it's perpendicular, right? That's fine. So this line that goes from P, and I'm just gonna draw it. We want that to intersect at 90 degrees. Okay, that's what we're looking for. Right, the altitude intersects the base at 90 degrees. In other words, how can I rephrase that? It is the shortest distance from this point P to a Q segment, or line segment QR, because it's at a 90 degrees. It's the shortest distance. So how can I figure out that equation? What is it that I need? Adrian?
Find the slope of QR.
Yes.
Yeah, right? I need, first of all, I need the slope of the altitude, but that's hard for me to determine given the information I have right now. I only know a point, right? I only have 1 point, so I can't determine the slope. But if I determine the slope of QR, I have 2 points. We know it's perpendicular to QR. So that's where we're manipulating our slopes. So let's calculate the slope of QR. Equal to delta y over delta x. y2 minus y1 over x2 minus x1. So QR I'm looking at, so I get 6 minus a negative 4 and 3 minus 8. So that gives me 10 over negative 5, which gives me negative 2. So that's the slope of QR. Now I want the perpendicular slope. So what's this perpendicular slope? What's the slope of the line perpendicular to QR? Negative reciprocal. And again, some of us on that last question of that quiz, we couldn't quite remember that. We just either did the opposite sign. So I don't want you to say opposite anymore. I heard a lot of people say, what's the opposite? That's only just half of it, right? It's the opposite sign, but it's also reciprocal. So here it's going to be 1/2, right?
Yeah.
So now we want the equation of the height. Well, we're going to start off with equation of a line format. Y equals mx plus b. We just figured out the slope, right? All that work, figure out the slope. It's 1/2 x. What's b? We don't know, right? We could try to see from the picture, but my drawing, my accuracy of drawing a right angle is not very good. So we just can't rely on the picture, right? We can rely on the picture to see if we're close, but we can't rely on the picture to get an exact answer.
Wait, we're trying to find the height of the triangle.
Yeah, or basically we're trying to find the equation of this line here,
Okay.
right? So we want the equation of that line. So how can we get b? How can we solve for b, Jane? Well, not quite the midpoint because we're not interested in the midpoint. We're not interested in the median, right? The midpoint up here? Yeah, so this might not be passing through QR. We can't say for sure if it's passing through QR, right? The median does, but we don't know if the height does. But how can we still calculate for b though? North?
You substitute -5 and
Yeah, we know that this point passes through our altitude, right? I mean, we're starting from there, so it's going to pass through it. So we're going to use that point to figure out what b is. So when x is -5, b is, y is -3. And again, in the quizzes, I saw people mix this part up. We put in the x value over here and the y value over there, and then you got the wrong value for b. So we need to take care of it, right? Take care of our work. So I get -3 is equal to -5/2 plus b. So I'm going to add 5/2 to both sides. And so that leaves me b is a -1/2. Okay. So therefore the equation is y is equal to 1/2 x minus 1/2. In other words, the y-intercept would have been somewhere around here, and if I draw a straight line, that would be the height. So I was off a little bit. But at least now if I calculate it, I can kind of see, okay, we're close. Problem is, we don't know this point here, right? We need that point so we can calculate the length of the height. So that's what we're stepping towards. So any question on just coming up with that equation? Okay. Most of the process, again, is just a review of the grade 9, come up with the equation of a line. Just knowing what points and getting that slope. So now that I have, we want to answer the second part. Determine on the points a segment QR. So we're on QR. So if we had our altitude here, where does it intersect? In other words, what is that point? We need to identify what that point is so we can figure out the length. So where's that point? How do we determine that? Maybe you guys maybe see it better if I actually drew my altitude like this or my height like this. And I took the base, this base, and I drew it like. Right? It's just two lines. So we're going to the point of intersection. Well, we know the equation of this one. Y is equal to 1/2 x minus 1/2. So know the equation of one line. How do we get that point of intersection? What else do we need? Well,
Negative reciprocal of the slope of the green line.
well, we have the equation of the green line. That's what step 1 was, right? We got our equation of our altitude. That's what we just did before. We got this equation of the green line. What else do we need now to get that point of intersection?
Do we need the equation of the blue line?
Yeah, now we need the equation of the blue line. All right? So what's the equation of the blue line? Well, start off with y. Let's go to mx plus b. What's the slope? Yeah, no, not 1/2. We calculated in the first slide, right? So what was the slope that we calculated there between Q and R? Yeah, it was -2 x plus b. So it wasn't that bad. We don't have to go back and recalculate the slope. We already did it once already. Now we just don't know what b is. How can we solve for b?
Sub in one of those 2 points.
Yeah. So we gotta sub in this point or this point. Which one? Yeah, I picked Q because it's got no negatives. So when x is 3, y is 6. So I got 6 is equal to -6 plus b. So b is equal to 6 plus 6. So b is equal to 12. So this equation is y is equal to -2x plus 12. Pardon? Did you get the same answer? So if we extended this line, we can see that, well, it's going to roughly hit around 12. So we're in the ballpark with our b value at least.
On the point of intersection then, do you equal each other? And just solve?
Nice. Okay. So here, what I want you to start teaching you though, as because we might make simple mistakes as we go along, one of the things that we could have did was -2 times 3 gives us 6. I've seen that. So now I subtract 6 from both sides, and I got b is equal to 0.
I wrote 9 by accident.
So even if you wrote 9 by accident, is it going to be 9?
No.
If you extend this line? No. So that's how you go back and say, you know what, that answer can't be right. Here we would have got, if we did -2x, there's no way this blue line's intersecting at the origin. This is how I sort of just, I want you to start being aware of the meaning of your work. Does it make sense, right? So when we make those silly mistakes, we've got b equals to 0 here, but does that make sense according to our diagram? No way. So that's where we sort of go back. So the point of intersection, as Katie has pointed out already, we just make our two equations equal to one another. So we're using what method? Yeah, we're using substitution in this case. So I have -2x plus 12 is equal to 1/2 x minus 1/2. So I'm going to add 1/2 on both sides, so 12 plus 1/2 is equal to 1/2 x plus 2x on this side. So So I get 25 over 2 is equal to 1/2 x. So x is equal to 25. Well, how did I get 25?
It's 12 and a half.
Oh,
Over.
You
Yeah.
forgot the 2.
It's a pretty much 12.5 divided by 2.5.
12.5. How did I get?
Yeah, it's 12.5 divided
But I got a half x here. No, I got 2.5 x here. See, even that makes some mistakes. I got 5 over 2x here. See, notice what I did? I got an extra 25, and I knew that that was way wrong. So I had to go back and look at my arithmetic. Really here it says 5/2 over, so now I got 25x is equal to 5. So 25 is equal to 5x. So 5, or x is equal to 5. Yes, Adrian?
Could you convert the fraction to decimal?
Yes.
If you use
Is if you want to use your calculator and you see that's a half.
How did you get 5 over 2x to equal 5?
No, I got 25 over 2 and a half x plus 2x is 5 over 2x. That's the part I slipped up on.
Yeah.
I forgot to add the 2x. So when x is 5, I'm going to pick one of my equations. I'm going to pick this one because it has no fractions. So notice what I'm doing. I'm doing work all over the place. I'm just drawing lines to separate my work. So I want to calculate y is equal to -2. So I want x is 5. So I'm just using this equation here, plus 12. So y is equal to -10 plus 12. So y is equal to 2. So therefore the point of intersection is 5, 2. And that puts us right around here.
That's weird.
Wait, what'd you just do?
That's weird. Oh. I know what I did wrong.
Wait, why did you do that second yourself?
Well, y-intercept was -1/2, not a half. That's really there. So my line should have been going through there. So that looks better. Right, Norm?
Yeah.
You caught the same thing I did, right? So the point of intersection is 5, 2. Yes.
Oh, so you just inserted the 5.
Yeah, so remember when we solved for one of the variables, when we did substitution, I solved for x. So I put x into one of my equations to get y now.
Okay.
What did this point give you?
So this point gave me this point here, where the green line intersects the blue line. Or in other words, where the altitude or where the height meets the base of our triangle. Now can we calculate the length of our altitude, the length of the height, which I think was question number 3. So now we have the point of intersection, which we said was 5, 2. Well, what's the length? How do we calculate the length? So here was our here was our height now. H. Yeah, this part now is the easy part, right? All that work just to get to the easy part. So h is equal to square root of x1 minus x2 squared plus y1 plus minus y2 quantity squared. So h is equal to square root. So my x values minus 3 minus 5 minus 5 squared plus minus 3 minus 2 squared. So that gives me -10 squared plus -5 squared. So h is equal to 100 plus 25. So that is square root of 125. And now that we're dealing with heights, I probably want a decimal with this. So anybody get me square root of 125? Sorry, 11 point. Thank you. So that's the height. What else do we need to calculate the area of the triangle? Now we need to determine the area of the triangle. So what other measurement do we need to calculate the area of the triangle? Yeah, we need this 11.18. So we need to calculate the length of the base. So base is equal to square root of
How much would they were?
106.
1.
3 minus 8
Oh, I love that.
squared plus 6 minus negative 4 squared. So here I got negative 5 squared plus. Is it the same thing?
Yeah.
Yes, you can. You set this up.
The same thing.
So that's really square root of 125, which is 11.18. So therefore, area is base times height over 2, which is equal to 11.18 squared divided by 2. Someone put that in the calculators for me. 62.49 units squared. Okay. Excellent work.
I missed the first step.
Okay, yes, it took me 20 minutes, but what was I doing? I was doing a lot of explaining. What you guys need to get a habit of is seeing that. I mean, is the math really that hard? No.
Yeah, because when you walk us through it, we already, it's like easier.
Yeah, but is the arithmetic that hard? No. It's getting to that, knowing what to do, knowing what to start. So that's why, this is why I scaffolded this question that way, right?
Museum, bro. A museum, bro.
Do we see where we're going with the perpendicular bisect?
Yep.
Okay. Yes, Adrian.
Final answer is actually 62.496, so it would be 62.
Oh, 62. I thought you said 64. So yeah, 62.5 then.
Yeah.
Okay. Not a big deal once you get to that part.
So
Just
you
calculate
do
work.
all the work and you
Yeah, that would suck. You do all that work, you type in the wrong answer from your calculator, you get half the mark off.
Yo.
It sucks, but it's life
You
sometimes.
get a bonus for these grids. Grids was
Okay, so for homework,
no homework. Yeah.
all I want you to do is just do all the questions that